Hi, welcome back. This time we're going to talk a little bit about how do we find um, perimeters and areas of irregular shapes. And these are shapes that can be made up of smaller regular shapes. So we just have to think, okay, what do we know? If in this we're trying to find the perimeter of example 6, I know that this side is 8 here. If I were to extend that out over here, this whole thing out here would also be 8. And so since I know that this side is 3, and I know the length of this one is 5. So that'd be 5 inches. And the same thing applies here. If this is 14 down here, then up here this is also 14. And since this part right here is 9, I'd say 9 plus 5 is 14. So this is also 5 inches. And then I can add up all of the lengths of the side. So I just take 8 plus 9 plus 5 plus 5 plus 3 plus 14. And I got, let's see, 1, 2, 3, 4, 5, 6 different sides. There's 1, 2, 3, 4, 5, 6 different sides. I'm adding them all up. So I can do that by hand. I can do it in the calculator. I'm going to do mine in the calculator. 8 plus 9 plus 5 plus 5 plus 3 plus 14. And just count them here. 1, 2, 3, 4, 5, 6. Make sure I've entered them incorrectly. I have, and I get that the perimeter here is 14 inches. Remember, the perimeter is just the distance around, and so it is a distance. It's just the length in inches. And then we have the area. And for my area, clean this up just a little bit. I'm going to chop this. You have different ways you could do it, but I'm going to do it this way. So this figure right here is 8 times 9, 8 inches times 9 inches, or 72 square inches. And that's just for this shape. This one is 5 by 3, 5 times 3, and that's 15 square inches. And then I just take the area, then would be the 72 inches plus the 72 square inches plus the 15 square inches. And my area then is equal to, let's see, 87 square inches. And that would be the area of that figure. All right, let's look at example 7. Now it looks like I've got 1, 2, 3, 4, 5, 6, 7, 8 sides. And if I'm not mistaken, they have given us 1, 2, 3, 4, 5, 6, 7, 8 different distances for each of those sides. So I think we're good to just go ahead and add those all up. So I'm going to do this just a little bit differently, though. Instead of adding 6 plus 6, I'm going to take 6 times 2. That one and that one, there's 6 times 2. And I've got 1, 2, 4 3 times. So that's plus 4 times 3. And then I've got 3 twice. So that's plus 3 times 2. And then I have 12 plus 12. And so It's the same thing. 6 times 2 is the same as 6 plus 6. I'm just kind of writing it in a little smaller way. So I'm typing this into my calculator. Six times 2 plus 4 times 3 plus 3 times 2 plus 12, and I get, this is my perimeter, and that the perimeter, when I calculate that altogether, is 42, and the unit is millimeters. So this time I'm going to do the area a little bit differently. This time I'm going to think of this all, let's use blue. All of this blue here is the space inside this figure. That is the area here. So I'm going to think of it as being like one big rectangle. This rectangle right there, with a chunk that's taken out of it. So the area of the big rectangle, 12 times 6, that's the whole thing here. 12 times 6, and that gives us all of that whole space there. So but then I want to take this chunk out right here. So that would be subtract 3 times 4. And 12 times 6 is 72. Minus 3 times 4, which is 12. And that would give me 60. And the units would be millimeters squared. And so that's the area. All right, let's look at example 8. Okay. I'm going to chop this in like this so that it's a square, 8 yards, 8 yards, 8 yards, and this would then also be 8 yards. And so this would just be 8 squared, or 64 square yards. But for the triangle, I'm going to bring it over here so that the side where I chopped it off is 8, and this is 6. This would also be 6, and I need to figure out what is the height to get the distance from the point. It's this distance right here, so that I can figure out the 1/2. Remember, the area of a triangle is 1/2 the base times the height. So we've got the base is 8. The height we don't have. But if I think of this as 2 triangles, then half of that is 4, and then I can use the Pythagorean theorem to figure out what this side is here. So 6 squared equals 4 squared plus, and I'll call it h for height, the height squared. And then 6 squared minus 4 squared equals the height squared. And again, I can plug that in my calculator. 6 squared minus 4 squared. You can do it by hand. It's not that hard. And that comes out to 20. So h squared equals 20. H then equals the square root of 20, which we can simplify. Let's say 20 is 2 times 10, and 10 is 2 times 5. And since I have a pair of 2's, I can rewrite the square root of 20 as 2 times the square root of 5. And so going back to that, the area of my triangle is 1/2 the base times the height. That's 1/2 the base, which is 8, times the height, which is 2 times the square root of 5. And half of 8 is 4. 4 times 2 root 5 would be 8 root 5. And so I could write that my area is 8 root 5 plus 64. And all of this would be in yards squared. But that's the exact answer. But I want to know what is that approximately. So I just type in 8 times the square root of 5 plus 64. And this is approximately, the area is approximately equal to 81.89 square yards. All right, let's look at example 9. All right, I've got half of a circle. So if the circumference is equal to pi times the diameter, and I'm going to use diameter because this 4 here would be this 4 here, which is the diameter of that circle. Half of the circumference, because it's just half of a circle, would be this divided by half. Divide both sides by 2. So that gives us pi times 4 divided by 2, which is 2 pi. And then you could add that to 4 plus 6 plus 6. 4 plus 6, 10, plus 6, 16. So that the perimeter of this figure is 16 plus 2 pi. And all of that is meters. But that's approximately equal to 22.28. 22.28 meters. And that would be the perimeter of this figure. Now for the area, the same thing. I'm gonna take the area of my half of a circle and then the area of the rectangle. For the rectangle, it's just 4 times 6, which would be 24 meters squared. For the half circle, the area is equal to pi r squared. So we're just going to take half of that. It's not pi squared, sorry, it's pi r squared. And so the radius is half of the diameter. So here I'm just going to make note that the radius is 2. And so we've got pi times 2 squared divided by 2. And 2 squared is 4, so that's 4 pi divided by 2 is 2 pi. So our area is 2 pi. The area of our combined figure is 24 plus 2 pi, and this is in square meters. And then as an approximation to that, that would be 24 plus 2 pi, 30.28. 30.28 square meters. So depending on what you're being asked for, this would be the exact answer. This is the exact answer for the perimeter, but you might want to actually know what is the approximate value. And then let's see, we've got example 10. All right, let's see what we know. If this is 16, then this is 16. And if this is 12, then this is 12. And if this is 16, then this is 16. And if this is 12, then this is 12. And we need to know, once again, what is this half circle? What is its length? What's the perimeter of that? For that, we need to know this distance right here. So because of this triangle, we're going to use the Pythagorean theorem. So we'd say 12 squared plus 16 squared is the hypotenuse squared. And the hypotenuse, we're going to call it d for diameter of that circle. So d squared. And I type some of this in here. 12 squared plus 16 squared is 400. And so if I take the square root of both sides, d then is the square root of 400. Which means that d is 20. So this is 20. Which means that its circumference, pi times the diameter, if we take half of it, because we just have half of a circle, then we've got pi times 20 divided by 2, and so that's 10 pi. 10 pi is the distance here. The distance all the way from the one side of the circle to the other side of the circle. Semicircle, I should say. So what have I got? The distance around this figure. I'm not counting the insides. I'm not counting this 16 or this 12. Nor am I counting this 20. It's just the outside. So I've got 12. How many times? 1, 2, 3. So our perimeter is 12 times 3. 1, 2, 3 12s. And then I've got 1, 2, 3 16. So there's 16 times 3. And then I have my 10 pi. And so I can type that in, 12 times 3 plus 16 times 3. And that gives me 84 plus 10 pi. Then the perimeter, so this is the exact answer. The perimeter then is approximately equal to 115.42. And again, there's no units here, so we'll just call it units. Now, for the area, there are two rectangles that are the same, 12 by 16, 12 by 16, 12 by 16. And so I can take 2 times the 12 by 16. This is the area of one of those rectangles, and if I multiply it by 2, that gives me twice the area. So 2 times 12 times 16, and that gives me 384. Then I'm going to add this 12 back here and this 16 back here, because then I've got this triangle. And that triangle is 1/2 the base, which is 16, times the height, which is 12. And that gives me 96. And then I've got my circle. We determined that the diameter is 20. That means the radius is half that. The radius is 10. So we've got pi times the radius, 10 squared. But we only have half of a circle, so we're going to divide this thing by 2. And 10 squared is 100, so we've got 100 pi up in the numerator. Divide by 2 makes it 50 pi. So I've got 384 plus 96 gives me 480 plus 50 pi. And altogether that comes to a total area of approximately 637.08 units squared. Once again, this right here is the exact answer, and this right here is the approximate answer. All right. That's it. Have a good day.